Okay, Bismillah ar-Rahman ar-Rahim. We'll continue doing these old exams questions. I think we did this one. Now we have this one. We have problem just with the infinity. So this will be limit t goes to infinity. Integral 0 to t e to the power x over e to x plus 3. By the way, this will never be 0. Dx. So I need to do this integration. Let me do it as an indefinite. See what will happen. Yeah, I'll let u equal e to the power x. So du is e to the power x dx. That will be what? Du over u square. This 3 I can write the square root of 3 square. That will be what? Tan inverse. So I have 1 over square root of 3. Tan inverse x over square root of 3. Not x, u. Let's see. And what is my u? Is tan inverse. U is what? E to the power x over square root of 3. Let's see. Okay. So this integral will be limit e goes to infinity. 1 over square root of 3 tan inverse e to the power x over square root of 3 from where to where? From 0 to t. That will be limit t goes to infinity. 1 over square root of 3 tan inverse e to the power t over square root of 3 minus 1 over square root of 3 of what? E to the power 0 is 1, so it's tan inverse 1 over square root of 3. Okay. Now, yeah, if t goes to infinity, then e to the power t goes to infinity. What will be e to the power t over square root of 3? That will not make a difference. Then tan inverse of e to the power t over square root of 3 will go to where? Will go to pi over 2. So that gives me 1 over square root of 3 times pi over 2 minus 1 over square root of 3. What is tan inverse 1 over square root of 3? So we need sign to be half, which is pi over 6. So that will be 1 over square root of 3, pi over 2 minus pi over 6. And what is that? Pi over 2 is 3 pi over 6. That will be 2 pi over 6. That will be pi over 3. So this will be my answer, which is pi over 3 square root of 3. Okay. This one, what is my problem? If this is 0, when cosine x equal plus 1 equals 0, so I need cosine x not equal to minus 1. So my problem is at pi. So I have infinite discontinuity. At x equal pi. You can check it's in infinite discontinuity by using the limit, but that's okay. So this one will be, you need to check in the limit x goes to, what is it, pi, you say from, yeah, more pi sine x, that will be infinity. That's true. If you apply it, you have 0 over 0. So apply Leibniz's rule, you get what? Cosine x over minus sine x. And that it's either plus or minus infinity. Yeah. Since you have what? Yeah, it depends 0 from right or 0 from left, huh? But you have infinite discontinuity. You have a number over 0, which is either infinity or minus infinity. So you need to check from right or left. But at the end, they have infinite discontinuity. Okay. So this one, I split it into 2 parts. 0 to pi sine x over 1 plus cosine x dx plus pi 3 pi over 2 sine x over 1 plus cosine x dx. Let me do one of them. Let me do this one. We have a problem with the pi, and that will be limit. T goes to pi from left. Integral 0 to t sine x. Let me do this integral here. We'll squeeze it here. Sine x. So I let u to be 1 plus cosine x. Du will be minus sine x dx. So I need minus and minus outside. That will be minus du over u. That will be minus ln 1 plus cosine x plus c. Ln u, where u is 1 plus cosine x. So this one will be limit. T goes to pi from left of minus ln 1 plus cosine x from where to where? From 0 to t. That will be limit where t goes to pi from left of what? Of minus ln 1 plus cosine t plus cosine 0 is what? Cosine 0 is 1 plus ln 2. Yeah. Now, as t goes to pi over pi from left, then cosine t go to minus 1. That implies 1 plus cosine t will go to 0. Yeah. And you have the absolute value that will be positive. So this one will go to minus infinity. Plus ln 2. So it goes to infinity, so it diverges. Okay. This improper integral is convergent if what? If p, huh? Okay. Yeah. I have problem just with the infinity. So I have limit. P goes to infinity. I want to check when it's converged. So let me do the calculation, then I will check the conditions. To do this integral, I think it's an easy one. I make 2.5 outside. No need to do it alone. No need to do it aside. You can do it in the same thing. That will be half. Yeah, that will be what? If this is u, avoid the substitution things. X. I need 2.5. That I will let you 1 plus x squared. Let you 1 plus x squared. Du is 2x dx. So that will be half of what? Integral u to the power 2p plus 1 du. Yeah, that will be half u to the power 2p plus 2 over 2p plus 2. plus c. And that will be half. What is u? 1 plus x squared over 2b plus 2 over 2b plus 2 plus c. Okay, let me write it here. That will be what? 1 over 4b plus 4 times 1 plus x squared to the power 2b plus 2 from where to where? From 1 to t. That will be limit t goes to infinity of 1 over 4b plus 4 1 plus t squared to the power 2b plus 2 minus. Substitute the 1, you have what? 1 over 4b plus 4 2 to the power 2b plus 2. We want to this limit to exist. This limit exists, it means this power. So we need this power to be less than 1. Yeah, for sure. And this power to be less than 1. Less than 0, sorry. Not 1. Less than 0. Negative. So it goes to infinity, that will make it, yeah, not less than 1, less than 0. I want it to be negative, so when applied t goes to infinity, that will go to 0. Otherwise, if it is positive, then it will go to infinity. So we need this 2p plus 2 to be less than 0. So I have 2p less than minus 2. So p less than minus 1. And that is my answer. Yeah, okay, 1. 0, huh? 2p plus 2 less than 0. I need the power to be less than 0, so that infinity with the with the negative power, that will go to 1 over infinity, which is 0, going to 0. This one, I think we did before. We do it before. Okay, let me do it again. What is my problem? My problem with, so I have x equal 2 over 3. So I have infinite discontinuity. At x equal 2 over 3. So I need to split this into 2 parts, 0 to 2 over 3. 1 over 2 minus 3x dx plus 2 over 3 to 1. Same function. Let me take the first limit, the first integral. Yeah, my problem is with this. So that will be limit t goes to 2 over 3 from left of 0 to t, 1 over 2 minus 3x dx. Let me do the integral here. 1 over 2 minus 3x dx. Yeah, it will be ln something, so that will make it blow up, goes to infinity or minus infinity. Okay. So I will let u is 2 minus 3x. So du is minus 3 dx. So I need minus 3 and minus 1 over 3 here. So I have minus 1 over 3 du over u. That will be minus 1 over 3 ln of u, which is 2 minus 3x plus c. So this is will limit t goes to 2 over 3 from left I'm doing it in details, huh? Minus 1 over 3, then 2 minus 3x, and that from 0 to t. That will give me what? Limit t. Let's squeeze it here. Limit t goes to over 3 from negative, from left. That will not make a difference. I have absolute value. Okay. Limit 2 minus 3t plus 1 over 3 x0. That will make it ln 2. A problem here. Since this will go to 0 with the absolute value 0, right? So all of this will go to minus infinity. So I have what? Minus times minus. I have infinity plus 1 over 3 ln 2, which is infinity. So it will diverge. I mean, with the absolute value, that will be 0 plus for sure. The following improper integral. I think we did this before. Yeah, this is for sure. I did it before. Yeah, it's this one. So it converges to y over 2. It's 9. Yeah, it's converged to y over 2. Okay. Then x over x. Yeah. I have problem with the infinity. This is x not equal to 0. I have from 1, so everything is okay. So this one will be limit t goes to infinity. 1 to t, then x over x dx. Let me do this integral here. Yeah, very clear. I let u equal ln x. Du is dx over x. So I have what? U du. Yeah, but this is du. And you have du. That will be u square over 2 plus c, which means ln x square over 2 plus c. So this integral will be limit t goes to infinity of what? Ln x square over 2 from 1 to t. That will be limit t goes to infinity ln t squared over 2 minus ln 1, which is 0. I know if t goes to infinity, then ln t will go to infinity. So this is goes to infinity. So diverges. Easy one. This one then whether the interval convergent or divergent. If it's convergent, finds its value. Okay. Yeah, my problem is that x equal 1. We have infinite discontinuity at x equal 1. So it means I need to split this into 2 parts from 0 to 1. 1 over square root x minus 1 dx plus 1 to 2 dx over square root x minus 1. Yeah. Let me do the first one. 0 to 1. Be careful. My problem is at 1. So I have limit t goes to 1 from left. 0 to t. Tx over square root x minus 1. That will be negative. Limit t goes to 1 from left. 0 to t. Dx over square root 1 minus x. Yeah, let me do this aside. It needs a minus sign because of that. Let me be careful. Let u equal 1 minus x, du will be what? Minus dx. So I need minus. That will be minus u to the power minus half du. That will be minus 2u to the power half plus c, which is minus 2 square root 1 minus x plus c. Okay, so this one will be limit t goes to 1 from left of minus 2 square root 1 minus x from 0 to t. That give me what? Limit as t goes to 1 from left minus 2 square root 1 minus t minus with the 0 minus 2. And that will be equal to what? This is t goes to 1 from left. This is 0. Yeah. So it will be 0 plus 2, which is 2. Now I'll do the second one. 1 to 2. Dx over square root absolute value x minus 1. Now this is positive. Easy one. That will be what? X minus 1 to the power half dx. Let me do it in one step. Yeah, I have problem with the one. You know what? Let me do it in one step. What, please? Change this limit. T goes to 1 from right. T to 2. X minus 1 to the power half dx. To the power minus. That will be what? Limit t goes to 1 from right to x minus 1 to the power half from t to 2. That give me what? Limit t goes to 1 from right. Let me make it like this. Of what? Substitute the 2. That 2 minus 1 is, that will be 2 minus 2 t minus 1 to the power half. 1, this is 0. So I have 2 minus 0, which is 2. So this is 2 plus 2, which is 4. And this is my answer. This one, let us, yeah, my problem just with the infinity. With the one also have a problem, but I'm starting from 2, so I don't care about the one. So that will be limit t goes to infinity. What is it? Go to the power t, dx over x minus 1 times 9 plus ln x minus 1 to the power 3 over 2. Yeah, for sure, I need to do this integral. 9 plus ln x minus 1 to the power 3. And it u to be 9 plus ln x minus 1. So du will be dx over x minus 1. So this integral will be what? This is du. So I have u was minus 3 over 2 du. Add 1. That will be minus half. So I have minus 2. Is it? Yeah. Add 1 minus half. That will be minus 2. U to the power minus half. Yeah. You add 1 will be minus. Okay. Plus c. So that's minus 2. 9 plus ln x minus 1 to the power minus half plus c. Okay, let me do the calculation. Don't forget the limit. That will be minus 2, 9 plus ln x minus 1 to the power minus half. Okay, from where to where? From 2 to t. That will be limit t goes to infinity minus 2, 9 plus ln t minus 1 to the power minus half. minus 2. 2 minus 1 is 1, then 1 is 0. Minus 2, 9 to the power minus 1/2. Okay, I need to close all brackets, okay. Now this one I need to be careful. If t goes to infinity, then ln of t minus 1, t minus 1 also goes to infinity, that will go to infinity. But 9, also 9, plus ln of t minus 1 goes to infinity. But I have an odd, I have a negative power. So this one to the power minus half, this one goes to 0. So I have 0 here, that will be 0 plus 2/3, which is 2/3, and this is my answer. Okay, cosecant. Yeah, be careful now. It's the integral of cosecant. Okay, the integral converges on the variable. Where is my problem? My problem is at infinity, at pi. Cosecant is 1/sine, so I have only problem at pi, huh? Infinite. Discontinuity at x equal pi. Okay, so I split this integral into two integrals. Okay, let me do one of them. My problem is with pi. That will be limit t goes to pi from left, integral pi over 2 to t. Cosecant x dx. Yeah, I don't like to memorize things. So is it ln cosecant plus cotan or minus cotan? I think minus cotan. Is that the integral of cosecant? Let me differentiate this to be sure only. Y prime will be what? I have over this, derivative of this, which is minus cosecant cotan. Cotan is what? Plus cosecant square. So I have cosecant common factor. I want to be sure my calculation is correct. That will be cosine, cosecant minus cotan over the same thing, which give me cosecant. So this will be the integral. Yeah. Ln cosecant minus cotan. It will not make a big difference, but just to be sure. Yeah, that will be limit t goes to pi from left. Ln cosecant minus cotan x from pi over 2 to t. That gives me what? Limit as t goes to pi from left of ln cosecant x cosecant t minus cotan t minus ln of what? Cosecant pi over 2 is 1. Cotan pi over 2. Cotan is what? Cotan is cosine pi over 2, which is 0 over 1. That will be 0. So ln 1, which is 0. So all of this is 0. So I need this only. This integral. Yeah. How to find this integral? I think I'll change it to sine and cosine. That will be easier for me. That will be limit t goes to pi from left of what? Then there's 1 over sine, so it's 1 over sine t. Yeah, if we take the limit inside, I'm getting what? Yeah, let me do this limit here. Limit t goes to y from left of 1 minus cosine t over sine t. Apply to have 1 minus minus 1. Is it? Yeah, it's 1 minus cosine. 1 minus cosine, so 1 minus minus 1, that will be 2 over 0. So I have infinity here, with the positive for sure infinity, so that will be infinity. Yeah, well, this is my answer. Diverges. Okay. This one, I think we did before. 4 over x minus 6. Yeah, this one as diverges to plus infinity. It's the same one. So no need to waste time. I think we have only a few problems to finish this section. So this is diverges to infinity, actually. Yeah, I think we have these 3 problems only. Yeah, this one is a lengthy one, a very lengthy one. Okay, I have a problem with the 1, but I'm starting from 2. It's okay. Here we have no problem. So I'm concerned only about the infinity. So that will be limit t goes to infinity of this integral. And here is the catch. Yeah, to find this integral, it's a little bit lengthy one. X plus 3 over x minus 1, x squared plus 1 dx. That will be a over x minus 1 plus bx plus c over x squared plus 1 dx. Cover method for this can be with 1, I have what, 4 over 2. That will be 2. Now I need to find b and c. Yeah. So I have 2 over x minus 1 plus bx plus c over x squared plus 1. That will be what, 2x squared plus 2 plus bx squared. Yeah. Minus bx plus cx minus c over this. So I have 2 plus b is equal to 0. So b equal minus 2. B equal minus 2. What else I have? I have 2 minus c. What is the coefficient of that? That will be 3. So c equal minus 1. Check. C is minus 1 and b minus 2. 2 minus 1, that will be 1. That will be correct. So this is will be the answer. So my b is minus 2 and my c is minus 1. So what is this integral? Yeah, I need to split this into 2 parts. Minus 2x over x squared plus 1 minus 1 over x squared plus 1. Okay. So that will give me 2 ln x minus 1. This is minus, this is u, this is du. So I have minus ln x squared plus 1. Okay. And this is minus tan inverse of x plus c. Yeah. Let me write this. These two, I can combine them in one. I can take this as a power. So I have ln x minus 1 square over x squared plus 1, which is positive. minus tan inverse x plus c. Okay, so this is will be limit t goes to infinity from where to where? From 2 to t. Okay, of what? Of ln x minus 1 square over x square plus 1. That will be x square. X square will not make a difference, but this is x square minus 2x plus 1 minus tan inverse of x. And that from 2 to t. So that will be limit t goes to infinity of what? Substitute t. I have ln okay. Ln of t square minus 2t plus 1 over t square plus 1 minus tan inverse of t minus ln of what? 2 minus 1 is 1, ln half. Ln 1 over 5, sorry, not half. Substitute the 2. I have 4 minus 4 plus 1, that will be 1, and this is 5 minus tan inverse of 2. Okay, I need to do this limit now. Not limit t goes to infinity. Let me do this one. Since ln is continuous, I can take the limit inside. And what is the limit of this? Same degree, so it will be 1. Ln 1, so all of this goes to 0. And this one goes to what? Infinity, that will be pi over 2. So I have minus pi over 2 plus minus also. Minus or plus. Yeah, minus. Then 1 over 5. Now it's plus. Plus tan inverse of 2. And this one, it's 5 to the power minus 1. So this is minus pi over 2. Plus ln 5. Take this as a power. Plus tan inverse of 2. And this is my answer. Yeah, it's not difficult, but it's calculation. You need to be careful. You have integral here, partial fraction. And also the limits, you need to be careful about it. Yeah, I think this problem, explain it. You need to do two things, integration and limits. Let me try to finish. This is infinity. So change this limit t goes to infinity. 0 to t. X over 1 plus x squared dx. Yeah, let me do it in one step. This is 2 and this is half. So it will be limit t goes to infinity, half ln 1 plus x squared. Yeah, this will be du over u from 0 to t. That will be limit t goes to infinity of what? Half ln 1 plus t squared minus half minus 0. Ln 1, which is 0. What will be the limit if t goes to infinity? Then 1 plus t squared goes to infinity. Then ln of this also goes to infinity. So that will be infinity diverges. Diverges. Okay. This is the last one. I have problem with what? With minus 2. So I have infinite discontinuity, infinite discontinuity at x equal -2. So that will be limit t goes to -2 from right, t to 14. That will be what? X plus 2 to the power -1/4 dx. Do the integration. That will be limit t goes to -2 from right of what? You add 1. That will be 4/3 x plus 2 to the power 3/4. Yeah, you add 1 and then divide by that from t to 14. That will be limit t goes to -2 from right of what? 4/3. Yeah, 14 plus 2, this is 16. 16 is 2 to the power 4. So the fourth root, that will be 2. 2 to the power 8, that will be 2 to the power 3, that will be 8. Minus 4/3 t plus 2 to the power 3/4. Very clear, this goes to 0. So you have what? 32/3. So it converges, and its value is 32/3. Yeah. Yeah, the remaining is just question from the book. I will stop the recording. Yeah, so this is the end of this section, except questions from the book, which I will do later. I will stop the recording. Thank you.